Yeah.
I mean,
Yes, Tommy.
what are the points?
How long have you been saving that one for?
What are you talking about?
Yeah.
Thanks, Andy. I appreciate it.
I'm gonna.
You can put it on your desk if you want. Here. Oh, come on.
It's the smell of calculus.
It's the smell of calculus.
Suffocating.
Yes. Asphyxiating. How you doing, Ian?
I'm good. I'm just kind of mentally.
I get you. I get you.
So
So yeah, just set those up, please. And just tell me this, whether it's disc or washer. That's it. That's all you get.
What I don't get fully, if you were to spin it around the y-axis or spin it around the x-axis, why is that not the same area?
It's harder to see with that shape because it looks kind of the same. But if you had something like this, here, let's do something like this. Something like that. And it was this area here, right?
Yeah,
Let
but it's the
me-
same shape.
No, it's not.
kind of
So
the
hang on.
same area.
Let's do,
I
give me a
mean,
second. Give me a second. Give me a second. Give me a second. All right, I got it.
Oh, yeah. Wait, which one? The first one?
There's one in the book kind of like this, right? So let's say it's this area
But
here.
also.
If you spin it around the x-axis, you get like a bullet shape.
yeah.
But if you spin it around the y-axis, you get something. And if I was trying to do this to
It's still the X,
scale,
it's still the Y.
Well,
No,
it's gonna be the same.
you get like a big,
Oh, yeah.
there's so much more volume here than here.
I was thinking X equals 10.
I don't
Yes,
get
sorry.
why.
Here's, well, look, first of all, there's way more area here than there is over here, correct? So I'm taking the bigger area and moving it farther. I'm tracing out more volume,
Further distance.
a further distance. That's why numerically it works.
Explode.
It depends on where you go. I mean, you would agree, like if I was making these out of plastic, you're gonna need way more plastic for this bowl shape than you are for this bullet shape.
Yeah.
And it's actually,
Oh, yeah, I did not think so.
you guys are on fire today. That's beautiful. Yeah, so that's kind of to scale.
Yeah.
Yes, exactly. Yeah, exactly. But
Yeah, I understand, but I don't.
yeah,
With me.
I know.
You know, I'll take your word.
It's 10 minus.
Like, I understand.
Listen, I understand it seems like bullshit, but
No, it's-
but the bullet, but it is kind of,
But which one Y?
thank you. By the way, you guys missed it. I had a quiz. I don't know if you guys remember that. There's the huge jazz house of fireworks, the huge ass house of fireworks, and like no one, it's like, no one, like, there was the huge ass house of
I was
fireworks.
probably stressed. It was a test.
Oh, that's a good point. So no one sees the humor in any testing. All right,
No,
keep going, keep going.
unless it says this is a joke.
This is a joke.
Right now.
Insert laughter here. I get you.
Yeah,
I
you
get
should
it.
still,
And
you
then
should still like
laugh
reread it
tracks
and I'll be
and
like,
shit.
oh, I get it.
Yes, you were just telling me if it's disc or washer for these. That's it. That's it. So you guys might be done.
Oh.
I
I don't know
understand.
if I did. 10 minus Y and then Y equals X squared. 10 minus X squared.
It's not a DX problem though.
Oh, my bad.
It's a DY problem. We already agreed on this.
Oh, so it's the square root of Y.
The
square root of Y.
This is going to be.
Yeah, so like 10 minus the square, 10 minus root Y. This, and then 10 minus this.
Well, for B.
And it's why, where's it going from? Two to four?
I get it here.
Okay, and then next thing you know, oh, what curve are we doing?
This.
We're going to
Oh, right,
Y.
because it's the slices.
So-
Oh, okay, it is the X, I was lying.
So
So X squared.
it's dy. Good, good, good.
One second.
So then the powder goes from here.
It's.
So the Y squared.
Yeah, that's.
And it's here.
Well, sorry. I'm thinking of
Go to this
the
part.
X.
Perfect.
Because this one's DX, so that means the last one had to be D.
Also.
You go to the furthest one first.
Slightly. Yeah.
Is that as far as you want us to go?
Yeah, just.
Wait, is that the first one?
Oh, I'm sorry.
Yeah, the first one.
Sorry. Hi.
Oh.
We have a lot.
Yeah. Kind of hustling.
When you're using horizontal and vertical,
Yeah.
is that for the discs or is it for
Huh?
It's
original line that's
It's for
going
the
on?
discs, not the original line.
So it's for the rectangles that create the discs. Yeah. It's how you draw the rectangles.
Okay.
And the rectangles are always perpendicular, but the axis are revolution. So another way to look at it is if you don't like that yours is vertical. So if you take the rectangle and just extend it, just keep drawing it.
So I would subtract.
So if you ever get it, it actually hits the x, it's at the x. If you extend it,
What is
it's
your
x,
x?
it's the y, it's the y. Whatever works.
It's just a more.
Yeah, exactly.
Exactly.
That's exactly what I was saying.
I love horizontal. Sitting on the roof of some church, some abandoned church, like next to the.
Wait, where's your y?
No, the big.
Oh, wow,
Yeah, you're bad.
y equals 10? Okay, that's.
So it's to get into
Yeah. Yeah.
Beautiful. Are you okay, Bria?
A for the first one is D1.
Yes.
Did you get this washer?
Oh, and it's,
Outside.
so.
So root Y.
What is it?
Root Y squared. One half Y. Are you still looking at the first one? Yeah, I can do it, but it's actually.
Don't worry about this stuff, to be honest. This is why I fail every test.
This is the part where I.
It's Tuesday, by the way.
I couldn't tell. Can they smell it?
I'm gonna say, just email me your suggestion.
Why is there black
Whoa.
smoke going?
All right, guys, I think we go out this door, we go up these stairs, I think all the way to the.
doing a fire alarm right now?
Wait, we are?
No,
You don't know?
there's just 3 lit wicks, so I don't know. I just want to make sure that we're prepared.
Oh, you got me.
Oh, it's like, after you count it on the computer, there's like a concerning amount of black smoke coming out of the candles.
Oh, man. I think I'm gonna move that.
Wait, you don't even have to set that up, it's just disc and washer?
Yeah.
Okay, see.
All right, are you guys ready?
2x.
All right, we're gonna start with this. Make sure these guys can see it. All right, guys, you're going around x equals 2. Cassie, disc or washer? Disc, beautiful. Y-axis? Cassie?
Oh, that is a washer.
That is a washer. Y equals 10. Cammy?
Sorry. Washer.
You got it. Good save, Cammy. Good save.
Ow.
You wish.
Ow. Good wish.
Right? Good. You're gonna do great at it. All right. We good? Cool. Here we go, y-axis. Shh. Guys, we got a lot to do. Shh. Sorry. Chloe. Excuse me, Haley. Excuse me. Shh. We must be quiet. Thank you. DX or DY problem? Maddie. Maddie. DY, good. Also, Xanon, disc or washer? Washer, good. So this is gonna be pi. This is DY. Minus pi. DY. Cassie going from where to where?
You were going from 0 to 4.
0 to 4, good. I like it. Hey, Maria. Maria, you're standing at the axis of revolution. You're looking to the far side, right? Do you need subtraction for that? What is it? Good. It is just x. It's a dy problem though. So Abby, what's it equal to? Root y. We good? Excellent, excellent. Then, the inner, right? Axis of revolution to the closer side. Haley, do you need subtraction? Nope, it is just X, correct? But I can't have it, so it's what? Love it. Y over 2, 1 half Y. 6. How many got it? How many got it? How many got it? You guys are killing it. You're killing it. All right, Y equals 10. So here we go. We're going around up here. First of all, Ian, is this disc or washer?
Washer,
Good. Dx or dy?
dx, because it's vertical.
That's exactly right. Well said. All right, integrating and up from where to where?
0 to 2.
0 to 2. Good. Love it. So, guys, it doesn't matter what the axis of rotation is, where you're going, it makes absolutely no difference. You do it exactly the same every single time. I'm standing right here. I go to the farthest side of the shaded area and go no farther. That's where you stop. Do I need subtraction for that? Yes, you do. Andrew, it's going to be the top Y minus the lower Y, correct?
Yeah.
What's the top Y? 10. Good. What's the lower Y? You got it. Don't forget to square the difference, right? So it's 10 minus X squared quantity squared. You guys are doing great. Then the inner. I'm standing on the axis of revolution. I'm looking to the closer side. That's this right here. Do I still need subtraction?
Yes.
Beautiful. Maddie, tell me what it is. 10 minus what? How many got it? Beautiful, beautiful. All right, so all right, let's go to page 80 first. All right, page 80. The first page was all area between two curves, right? So hopefully you guys are getting through the algebra, okay, of like setting them equal to each other. The biggest mistake that I'm getting for people doing it on the graphing calculator is not putting it into one line. It has to be one curve minus the other into Y1. Don't do Y1 and Y2. It is going to be a train wreck. Trust me. It takes forever to punch all that stuff in. All right? It is Y1 minus, excuse me, it is one curve minus the other into Y1. And then also put Y equals 0 in for the second. Sound good? I hope that helps you. All right. Should we start with 21?
Yes.
Okay, let's start with 21. Are the curves Y equals 4?
It's Y equals 4 and Y equals
Got it, got it. So guys, typically the issue is you've been dealing with just Q1 only. This is not a Q1 problem. It's the first two quadrants. So it's Y equals X squared. It's the whole curve. It's the parabola. That might be throwing your answer off maybe. And then this is Y equals 4. Now again, I'm gonna give you the graphs, right? So this shouldn't be an issue in the quiz. By the way, let's talk about the quiz really quick. So it's just 6, 1, and 6, 2 only. You guys all with me? 6, 1, and 6, 2. You're gonna have to integrate like very little. Most are gonna be set up because I just want to ask you more questions. So it'll be calculator and non-calculator. Probably guess what's gonna be on the calculator portion, right? Yeah, that's it. So just wash your area between two curves. It'll be on the block day. So tomorrow or Thursday. I have you guys tomorrow. Yeah. Okay, cool. So guys, I think, Chloe, help me. This is going around the x-axis. Is that right?
Yeah.
Okay, cool. So hey, Zach, say, is it disc or washer?
Yes.
You sure? Washer. I think it's washer, isn't it? Here's why. If you're going around the x-axis, isn't it this area here? This area is disconnected from the axis of revolution underneath, like over here and over here. So you're going to start with more volume than you need, but then you have to take it out. Are you seeing that, Zaxi? And listen, if you're having trouble seeing that, this process is going to be difficult, right? Because you got to kind of know where you're going with this. Are we good that this is a washer? Yeah? Okay, good. Haley, dx or dy? These are dx problems. We good? By the way, this is what? -2, 4. This is 2, 4. This is 0, 0. Good. Abby, integrating from where to where? -2 to 2. Beautiful. Right? Low x, high x. Zane, you okay? All right, so then check this out. I usually draw it like somewhere in between. It gets a little confusing if you try to draw it right here where it's like disc-ish. If you're going to use washer, draw it somewhere in the picture where it is more washery, like over here somewhere. So I stand here, I go to the far side. Andy, you need subtraction for that? What is that?
X, no, Y, I think.
And it's just y, good. But I can't have it, so it's just 4. You guys agree? You're measuring from the x-axis up. And then to get the inner, I start here and just go to here. Cami, do you need subtraction to find just this? No, what is this? I love it. That's it. Were you just not getting the answer? Or?
No, it was just because I don't have the pictures
Gotcha.
and I can never visualize them.
Yeah.
So.
I get it. I'm going to give you the pictures.
You are.
I will not give you the pictures, guys. I think we talked about this yesterday. I won't give you the pictures on area between two curves.
So it's like 6.
You don't need it. Who cares?
It's just F X and GX, right?
It's what?
F3 is
Set them in front of
7
each
equal,
other.
and then- Okay,
Make sure you progress from left to right, points of intersection. Don't skip any, right? Yes, Evan?
Can we do one of the area between two curves where it's like X equals Y?
Yeah, sure. Is it just by hand?
Yes.
All right, go for it. What is it? Give me the curves.
Just 100%.
All right.
Curve X equals Y squared. X equals,
I'm sorry, what was it?
X equals 3 minus 2Y squared.
Got it. Hey, guys, it makes absolutely no difference what letters you do it in. Do it the same way every time. I'll take this, set it equal to this. I did mention you could switch out X's and Y's if this really bugs you, right? But I'm just gonna do Y squared is equal to 3 minus 2Y squared. What do you do now? Move it all to one side, 3Y squared minus 3, plus 3.
Minus 3.
It is minus 3, thank you, yes, algebra, goodness gracious. Then what do? Solve for Y, good. How do we solve for Y?
But
Yeah, we can pull out a 3, then factor, so it's 3, Y plus 1, Y minus 1. What are my Y intercepts? Good. You only have 2 points of intersection. I can do it with one integral, right? So I'm just going to integrate from -1 to 1, and I'm going to use this. 3y squared minus 3 dy. You can make them x's if you want. Isn't it true that once I get to here, I've already subtracted one curve from the other? That's how I set it equal to 0, right? So you've already got it, 1 minus the other. All I got to do is integrate. It's going to be what? Y cubed minus 3y. Going from -1 to 1. Plug in 1, plug in -1, subtract them. So that's what? 1 cubed minus 3 times 1 minus -1 cubed. It's 3 times -1. -2 minus -1 plus 4.
that's not right.
It's
-1
2.
plus 4.
Is this wrong? This is
That
-1.
one's
This is
wrong.
1 minus.
It's the other one, it's 2,
Is it?
yes.
-1.
So it's positive 3,
You just said
plus
plus
positive
4.
3 plus a negative
I
1.
did. Fascinating. Shh, let's let that be our secret. Okay, good. So this is going to be -1 plus 3. Answer's fine. Don't forget, don't abs the value till you get to the very, very end. Kimmy,
How do you do 3 equation?
with the 3 equation.
Or like on number 7 or page 70.
Okay, give me the curves, please.
There's a calculator one though. So
Was it? Okay.
It was y equals x cubed and then x equals -x.
And x is equal to 2?
Yeah.
Is that what you said? Okay, cool. So this is just a single curve, right? So there's like no points of intersection. So they have to cut it off somewhere. So if you have y equals x cubed, it looks like this. So I'm going from, is there another curve? Or is that it?
No, it's
The x-axis.
Oh, and the x-axis. Got it. So y equals 0. So it goes from over here to x equals 2. You guys with me? So what you could do is this. You could go from -1 to 0. This doesn't hit here. At -1, 0, and at 2. You guys all with me here? And then check this out. I could just do x cubed. So that'll give you this area right here. And if that turns out to be negative, which it probably will, you just absolute value it. Kimmy, are you with me? Okay, and then what I'm gonna do is I'm gonna add this then, from 0 to 2, and I'll do x cubed again. The other curve is y equals 0, right? So this technically should be 0 minus x cubed, and this should be x cubed.
Wait, so what would you enter on the calculator?
This thing calculated.
Yeah, so if this were a calculator problem, I would just enter x cubed.
Not negative.
No, I would just enter x cubed. And I would first integrate from -1 to 0. Absolute value of that number, right? Because when you do this on your graphing calculator, you're just gonna see this.
Yeah.
Right? And if you go from -1 to 0, it'll shape this. It'll be negative, so your absolute value. And then you do it again from 0 to 2, and it'll shape that. And that'll be positive. You just add them together. Basically, the two curves are x cubed and 0. So in your y1, you just do x cubed minus 0.
That's easy.
It just seems way harder, but it actually is pretty easy. Yeah. And then they have to give you these, Kimmy, to cut it off, basically. So that's why they give you those x bounds. I'm going to actually give you curves on the quiz, so you won't have to worry about this. But that's actually pretty easy. Okay. Is it 11:20? Is that right? Okay. All right. We'll spend some more time tomorrow morning if you guys have questions. All right. I'll give you some optional review problems tonight. All right. You guys take your notes out, please. We got to do 463. This will not be on the quiz, and it won't be due until Friday. But we got to knock it out. It's like almost the last thing we got to cover before the end of the semester. Okay. So the nice thing about this, guys, is that it'll help reinforce some of the measurement techniques from disc and washer. I hope. Because all that stuff is exactly the same. And by the way, the horizontal and the vertical, all that's still the same, okay? All that stuff will still be identical, okay? So it's 6.3, and it's called the shell method. So it's just a different way of going about calculating volume. You're going to get exactly the same answer. The reason we need another technique besides disc and washer is because sometimes disc and washer doesn't work. I'm not going to get into when it doesn't work yet. I'll explain this later, like later in the week. But for right now, you just gotta go. All right. So if I have something like this, I actually have models that I can send around to kind of explain what's happening here. They were 3D printed. They're in storage, unfortunately, so I can't hand them around. So I'm just gonna have to go with my drawings. Yeah, I don't know why I'm even mentioning that I have them, but I'll show you to you later because they're fascinating. All right, so this is y equals x squared. This is x is equal to 2. This is y is equal to 0. So these points are 2, 0, 4, 2, and 0, 0. Excuse me. All right. Thanks, guys. I have my C game going today. There's maybe C minus, possibly. That's all right. All right, I'm gonna go around the x-axis, all right? So the difference between this method and the other method is, what we're gonna do is, we're gonna draw rectangles that are now parallel to the axis of revolution, okay? So before they were perpendicular, and they created discs, right, like coins, basically, and you would get like a stack of coins, basically. This is just a little bit different. You're still gonna get the same like sharp tack like shape, right? That's drawn three-dimensionally. So before, what this was, again, these are just stacks of coins going this direction, right? This coin over here was just really small, basically. If I turn this rectangle around, so that it looks like this, what I'm gonna get, see if you guys can visualize this. You take that rectangle and you revolve it around the x-axis, you're gonna get like a piece of pipe, like PVC pipe or copper pipe, whatever, right? So this is gonna go around here. It's gonna look something like this. and it's gonna be infinitely thin. So in order to create this shape, instead of like having a stack of discs, what I'm gonna have are pipes placed inside of pipes. And they're gonna be different in how long they are and the diameter of them. So for instance, this outermost pipe here, and by the way, when I do this, I'm gonna get a pixelated thing like this. It's gonna goes without saying, you guys know the drill. Okay, so the innermost pipe is gonna be this long with a really small diameter. The outermost pipe is gonna be really short, but a really big diameter. All right, so they're all gonna be measured from here, basically. So this pipe right here will go from here to here. It'll just have this diameter. So if I looked at this end right here, instead of seeing like just a flat surface, it'll look like tree rings because there'll be pipes placed inside of pipes. Now, can you just kind of visualize what's happening here? So the pipes are just going to differ in diameter and how long they are. And then what's going to happen here is if I force it to be infinitely thin, I'm not going to get a pixelated picture. I'll get a nice smooth picture and it'll look just like this. There'll just be an infinite number of pipes placed inside of pipes. I'm not even sure that that's necessary to see, except to be able to draw a single pipe, and then the rest comes out in the formula, right? So put this in your notes, please. The formula for the shell and you should memorize this. It's going to be 2 pi times the radius times the length times the thickness. Two pi RLW. So, but it's the same techniques as before. Now check this out. Thickness right here, this will always be dx or dy. So that's nice. So really, the only two things you gotta find now are radius and length. That's it. If you can get those two, you're good to go. It's really no different than like disc and washer. You just gotta find this and you gotta find this. It's the hardest part. Everything else is partial credit. All right, so we work through a couple? Okay, good. Here we go. Questions before we get going? Feeling okay with it? Okay, sweet. Love it, love it, love it, love it. All right, so let's do this problem right here. First of all, oh, by the way, one of the things that might help you remember this is that this is the shell method. The rectangles are perpendicular to the axis of revolution. They're parallel. Those are L's. Shells, parallel. Okay, good. So, dx or dy problem? Horizontal. Horizontal. These are horizontal. This is a dy problem.
Oh,
No.
It's horizontal. What?
it is, yeah.
Horizontal. So I got 2 pi dy integrating from where to where? Low y to high y. It's exactly the same as disc and washer.
Yeah, actually, this is why. This is like something I just tell us like
Sometimes.
but is there like certain ones that you absolutely have to?
Hold on. Don't worry about it. I just want to get this taken. Oh, and by the way, you guys agree? If I'm going around the x-axis, I can use disc or shell. They both work here. Yeah. So,
Isn't the DSL?
all right. So now check this out. Let's talk about the radius. That's a good point. Radius goes from the axis of revolution to the rectangle. What is that radius? What is that, Anna? Mm-hmm. Do I need to replace it? No. It's dy problem. You know the picture I have in your notes? From the x-axis up is y. It doesn't matter if you're going to a rectangle, a curve, axis of rotation.
This is better.
This is better. It's the same thing. It's just y. You're just going up from the x-axis. That's y. All right, the length of the pipe. Do you guys agree the length of the pipe is the length of the rectangle? Yeah, it's just from here to here. Do you need subtraction? Andrew? Yes, you need subtraction. So I'm going this direction, so isn't it rightmost x minus leftmost x? This is just like disc and washer, right? So what is rightmost x? 2 minus, what's this x? That x is y. It's x1 minus x2. So it's exactly the same as what we were doing before. You're just putting it in a different form. Some people like this a lot better. Right? Yeah, so all you have to do is distribute the y, anti-derive it, plug in 4, plug in 0, subtract it. You think it's easier?
I don't know, it's like finding two things compared to.
Yes. True. All right, now hang on here. Are we good? Any questions? What do you think, Cassie? You okay?
Yeah.
All right, cool. Let's do same shape. Let's go around a different axis now. So let's do something like this. Everything's exactly the same, except now I'm going to go around here. Do you guys agree you're going to get like a volcano shape? Not that it really matters, but it's going to be kind of a volcano, right? It's got a hole in it for sure. All right, so how do I draw my rectangles, Abby? Beautiful, parallel. All right, so by the way, if I draw this in, right? Something looks like that. Those are like the shells going around here. You guys see that? Dx or dy problem? Vertical, dx, good. So 2 pi, dx, partial credit. Going from where to where, people? 0 to 2. Has nothing to do with the axis of revolution. It's all just about the enclosed area, right? So low x to high x. All righty. Am I going too fast? Are we okay? Sweet. Radius. Careful. So doesn't the radius, kind of like when you're doing washer, go from the axis of revolution to right there. Do you need subtraction for that? Bet your bippy. X1 minus X2. So what is X1? 4. What is X2? Listen, I'm only putting in 4. I could have left X1 and X2. It doesn't really make sense because they're both X's. But the first one's constant. That's why I put that in. So it's 4 minus X. And I can leave them. It's a dx problem. I don't have to change them out. Ian? Okay, you good? So, Arden, go ahead.
Let's from 0 to 2.
Because it's 0, 0 to 2, 0, 2, 4. So remember, it's a dx problem. So it's the lowest x to the highest
You don't
x.
include the 4.
No. Remember, it doesn't matter if it's disc, washer, or shell. It's all about the enclosed area. Just this area here, that gives you your intervals. Cassie? That's part of the formula. You always have a 2 pi. You're good. All right, so now, you hanging in, Shayna? Okay. You just got to get the length. Isn't it the length of the rectangle? Do you need subtraction for this?
No.
What is it, Maddie? Maddie? Good. It's y. Can't have a y. It's a dx. Okay. And this is question always comes. People always ask, right? Like last period, people are like, well, wait a minute. Don't you have to like subtract out the inner? You don't. There's nothing to subtract. These are pipes. They're hollow. So you just stop putting pipes inside of pipes. Like this innermost pipe is already hollow, so it already has a hole in it. There's nothing to take out. You do have to take it out if it's a disc, right? Because you start with like the solid coin and then you have to take out the metal. But this, you never have to do that, ever. Kind of nice. You hanging in there, Arden? Okay. Let's do a couple more just to make sure that we're good. Tammy, are you good?
Just no.
Are the ones that you like have to use the shell?
There are, but don't worry about it now. So all the ones I'm gonna give you now have, I'm just gonna tell you, just use the shit, okay? But we'll talk a lot about it. Once you see it, it's like, oh, well, that makes sense. But don't worry about that yet. It's too much. In fact, if this is bugging you, like this is like, this is hurting my head and it's too similar to the other one, forget about it. Just wait till the quiz. Okay. All right. Let me change up the curves. Let's do the one we did in the warm up. Y equals x squared. Let's do y equals 2x. You guys doing okay? You feel it? Love it. It's almost perfect timing. All right. Chloe, are you doing okay?
Yeah.
All right. So let's go around maybe y-axis. This is 0, 2, 4. All right, Andrew, are you ready, man?
Not yet.
All right, Andrew, if you're drawing in the rectangles, what do they look like? Beautiful. Vertical, vertical, vertical. Which means, Bria, dx or dy problem? dx, perfect. Got 2 pi up front. Got dx here. Going from where to where, Shannon? Love it. All right, Andrew, you ready? I don't think you need to draw like the overall 3-dimensional picture, but I would maybe draw just one piece of pipe, right? Based on this, just kind of get your brain around what you're doing. Just like this. Great. So, and if I'm going around here, I'm going out to here. That's my radius. What is that?
That's just X.
Love it. Yeah, and. I will.
And then if you just keep doing it.
Okay. Is actually. That's how long the pipe is, right? What is it? Is it? Yeah, giddy up. It's y2 minus y1. Right? Don't I need subtraction here, guys? All right. But this is a dx problem. So here we go. What is y? What is the upper y? 2x. What is the lower y? Beautiful.
Why is it
Just x.
just X?
Got it. Because if you look in your notes, that picture that I have in your notes that I said I was going to refer to about 10,000 times, I said that if you go from the y-axis over,
It's just
it is,
a.
guys, it is always x. It never will be anything other than x. I don't care if you're going to a curve, an axis of revolution, anywhere. If you go from the y-axis over, that is x. You got to force your brain to accept it because you're like, it must be harder than that. It is not harder than that. It's true. Also, if you're going from here up, Chloe, it's just like this was y, right?
Right.
It's the x-axis up. It doesn't matter what you're going to. Yes. Haley?
So like when taking that, you just like for the radius, you just go from axis of revolution
Uh-huh.
to the
Rectangle.
to the
To the rectangle. By the way, can I just show you something here? Because I know this is what, I'm assuming this is what's bugging you. Normally you go to a curve, don't you? Okay, doesn't it depend on where I draw the arrow? So stick with me here. If I went to here, I'm going to the upper curve. If I draw it down here, I'm going to the lower curve. You can't replace, right? You don't know which one to replace it with. It doesn't make any difference. It's just x. That's why x applies to both curves. That's why it doesn't matter what curve you go to. You're just going to the rectangle. It's just x. That's it. End of story. Yes, sure.
So when you're finding the length, is it always like top line minus the bottom line?
If you're not going from an axis. Always, always, always. All right, so we got a couple minutes left. Do you want to do like the other one we did in the warm-up, like y equals 10? Just real quick, just to make sure that we're good. All right, let's do it. Okay, so y equals 10. The shell, yeah, let's definitely do the shell. Because we can do tomorrow morning, we can do discrete washer. Let's get rid of this. Okay, so we just do it together. All right, let's do it. All right, so what do the rectangles look like? Parallel. So they're going to look like this, right? I don't really want to draw it, but you guys agree it's going to look bad. Okay, good. Dx or dy?
Y.
Dy, good. So it's 2 pi. This is dy. Going from where to where, guys? 0 to 4, right? Low, y to high. Sexy, you still good? Okay. Zayden, you hanging in there?
Yeah.
You're good. I want to make sure you're not distracted. So now, the radius. Radius goes from here to right there. Ten minus y. You have to use subtraction, right? Everybody seeing it?
And Y is just because it's the arbitrary.
You bet. 10 is always 10, variable y. Upper minus lower. You got it. Here's how long it is. We need subtraction. Yes, you need subtraction. You're not going from the y-axis. So it's this x minus this x. But it's a dy problem, so what's this? What? This is x, good, but it's a dy problem. Root y. And let me just stop right here. This is the rightmost curve. It's this all for x. It's root y. What's this? Y over 2. I erased it. Minus 2x. It's a tough crowd, man. You good, Maddie? That's what I'd like you to work on, please, full Friday.
Page 437. 1, 3, 9, 13, 14, 19 through 21.
This is optional.
No. Do. You don't, to be honest with you, everything's optional.
Well, is it gonna affect my grade?
This one will.
Do you want us to like solve it out all the way?
No. Oh, yeah, set up. No, it's a great question. Set up, just set up. Page 428. Oh, I see. I now I know your hesitancy. Yes, now I know why you're worried. Yes, I got it.
Is the optional review?
You just review, just more discrete washer. So if you want to try those, you set those up too. Guys, and listen, you're only gonna have to go through maybe one. I'm not gonna have you do very much integration. Not that it's not important, but I can just ask you more problems with the other part. Oh, sorry, Chloe. And are you doing okay?
Yeah.
Love it. Cool. All right, people at home, thank you. Goodbye.